Hi, everyone who's joining us. We see a lot of people still joining, so Rick and I will wait maybe one more minute. This is Cypress and DHL webinar. I'm Gleb Bahmutov from Cypress, and with me is Rick Fleuren from DHL. And why don't we go to the next slide? So we're using Slido, right, for polling. And while we're waiting this minute, you can take your phones, right, take a picture of the QR code and then open on your phone, on your computer. And for example, even tell us where you're joining the webinar from. So I'll type Boston and I'll click send and it reflects. So whoever wants to, just go to Slido, enter code DHL, or just use QR code or use direct URL. We're gonna use this Slido event to ask questions. You can vote on questions, you can ask your own questions. And at the end of a webinar, we're gonna answer as many questions as possible. I see Moldova, my hometown from Chisinau, yeah? So Rick, how are you doing?
Oh, wow. Toronto, London, very cool.
Yes.
I'm doing great. How are you doing?
As you can see, I'm excellent. Thank you so much for joining. Thank you so much for taking time to actually put the slides together. Right? You've done a lot of work, and you've done a lot of Cypress work. So excellent. So we see about.
Well, you haven't seen the slides yet.
1/3 of all people are joining the Slido. Yeah.
Oh, very nice.
Yes, so thank you so much.
So lots of people from London, I see.
Updating. Yes, yes.
Yeah.
London
Lots
has
of
a
from
big
London.
QA
very
community.
Nice.
Okay, it's 2:04. Why don't we start? So as I said, I'm Gleb Bahmutov, VP of Engineering at Cypress, and with me is our guest, Rick Fleuren, a software developer from DHL. Rick, do you want to quickly introduce yourself?
Yes, of course. Like you said, Rick Fleuren. I know we talked about pronunciation, but well, I guess you nailed it a little bit. Anyway, I'm a software developer, currently working at DHL Parcel in the Netherlands. I've been working there for, I think, 14 months now, something like that. And it's the first time I was introduced to Cypress, actually. So that's nice.
Nice, nice. And you put an idea and you put the slides of this webinar, and it covers very interesting topic, right? We have a lot of people trying to run Cypress tests and application using Docker Compose. So it's great to have a dedicated webinar to just serious example of Docker Compose. So we're going to cover these topics. First, Docker Compose, how Rick runs tests in parallel on Jenkins, and then how he runs tests in parallel via Docker containers. And then there are a couple of pitfalls which you might find very interesting. And then at the end, we'll answer any questions. So again, go to Slido and use event code DHL, and we'll get the questions there. So Rick, why don't you take it away and tell us about your test and the application?
All right. So we have a very big application at DHL because we serve a lot of customers at DHL. So what we are building actually is software to create labels. So when you send out a package, you'll get you want to send a package to maybe the other side of the country. I don't know. So you create a label, and then you can stick it in your package, and then the package goes into the network and will get delivered. So we build the software.
How many people use this application?
Create labels to start the process. Well, een val ik weer door de mand. I don't know the exact number, but right now I think we're doing maybe 100 labels a day. So I'm going to get an ass kicking about this because I don't know the exact numbers, but we have a lot of numbers, and
No, it's fine.
given the crisis going on worldwide, the DHL is only growing, right? So we're in a very good market right now, and a lot of packages are being sent right now. So here's a screenshot of one of our applications, and as you can see, we have a lot of different options. It looks like an email client inbox, which is deliberate because we want people to feel like they're actually sending an email or a package in this case. So you see many buttons. They all do exciting stuff, and we were figuring out how to test like the entire chain, right?
Right.
So we have the front end, we have the back end, and we'll tell a little bit more about that later. But it's a big application with many factors to consider.
Gotcha. How is it architected?
You mean like the stack?
Yeah, like the stack, right?
So let's see. I actually made a slide about that.
Nice.
Yeah, I know. Yeah, there you go. So we use Docker. And every deliverable we have is a Docker container. So which actually enables us to do quite a few releases each year. I think we do around, I don't know, 600 production releases every year, something like that. So we are continuously releasing to production.
Nice.
Because we use Docker, we can easily deliver new containers to our two environments. So we have an accept environment and our production environment. So inside these Docker containers, we have several microservices, and I will show you which ones later on. But to give you a global feel about which microservices we have, if we go back to the previous slide where you can see the application, we have like an API. The API also serves for different websites, for different applications to our customers. And then we have our label service. We have a capability service, which this determines what you can do on the site, and all these services they are connected to each other, and then in production it's managed by Mesos Marathon. But locally we use Docker Compose.
Gotcha. So why don't we go to the next slide, because we wanted to actually poll people if they're familiar with Docker Compose and the level of experience. So if you go to the next slide, on slide we have a poll going on right now. What's your experience with Docker Compose? So why don't we take a maybe 30-second pause just to see if we have to kind of give a basic intro to Docker Compose before you jump into more advanced explanation, right, Rick?
All right. Sounds good.
I can see that. Yeah, good thing we put this poll, because we see a sizable chunk of people who need an introduction to Docker Compose, which will not going to be long.
I think that would be good. Otherwise, the rest of my talk will be like pure voodoo magic for a lot of people.
True. Lots of small code samples, right? I mean, big code samples, small font. Excellent. So approximately a half of you said, answer the poll with sizable chunk saying no experience or just basic experience. So why don't I go through next slides? Otherwise, I would have skipped them. Oh, wait. Sorry, it completely. Okay. So a lot of people run Cypress locally, right? So imagine you have host machine that runs Mac or Windows or Linux, and you run your web application that you want to test on that machine, and you run Cypress locally. So these are two normal applications that just interact on your machine. So this is how people start. There is no isolation. It's literally running, starting from one terminal, an application, and another terminal, Cypress, and they can talk to each other on localhost. But maybe your application is complex. Maybe it needs something that your host machine doesn't provide. In that case, you can run your web application inside a Docker container. So we're still not using Docker Compose yet. We're just starting an application in a container. And we can run Cypress locally. And it can talk to that web application running inside the Docker container on your machine. But imagine that your application is complex. It probably has several services. You all want to run them inside separate containers. And you probably want to run Cypress inside a container as well. So it is isolated from the rest of the machine. And it's repeatable, right? It produces the same consistent screenshot. So in that case, you probably want to use a tool like Docker Compose that runs web application in one container and then runs Cypress in another container, and then sets up this connection so that Cypress can actually see your web application. And we do have examples. So as you can see on the left, we do have examples of running in this setup. This is a typical Docker Compose file. It defines services as highlighted here. We have the first service. In this case, we call it web, and it runs, in this case, Apache. So we start an Apache web application. We expose some ports like 8080, and we map it. This is one service, one Docker container. And then there's a second Docker container, we'll call it E2E. It will run Cypress. And it depends on this web, this first service. Right? So this Docker Compose allows us to create those dependencies, and one container will wait for another container to start, and then it will connect the local domain addresses. So I can say Cypress base URL, like where my tests are pointing at, will be just http://web, which is the name of the service. And then we run Cypress. And we also can just map our local spec files into the Docker container. So we don't have to copy files over. They're just mapping local folder into the Docker container folder. So Cypress can find the spec files. And you can even go beyond that. Sometimes you might be able to run your web application locally on a machine, but run Cypress inside the container. So we do have examples of that. So this was introduction to the Docker Compose. And Rick, why don't you take over and show a realistic Docker Compose stack?
Well, here is an example of our Docker Compose stack. I truncated the file a little bit because otherwise it will be way too long. But essentially, the base is the same. So what the Docker Compose file entails is it creates a small network, and all the services inside the network can talk to each other, which is really nice because you have an enclosed system, and as long as you don't map any ports to the outside world, it will be an enclosed system to run, right? Mm-hmm. Which is nice because when we go and see the Jenkins side of stuff, the continuous integration side of stuff, you don't want two different builds mm-hmm. exposing the same port to the outside world, because when you do that, then you can't run two consecutive builds.
Right.
That's bad. So the Docker Compose file ensures us that we have a single network of services running together. So nice. Here we have the DHL capability services. Always it's truncated to the 3-letter acronyms, of course, because 3-letter acronyms are you need to have 3-letter acronyms everywhere. So it's just part of life.
You have to.
So, yes, I know. So these are a few of these services we talked about in the previous slides. So we have the API, we have the label service, so we have the capability service, and everything runs inside one Docker Compose file so we can spin up the stuff locally.
Right. So many containers spun up automatically.
Yes, yes. I think we have now, like, in our current environment, I think 14 containers.
Oh.
Let's see. So, and then besides the Docker Compose file, we have a file with overrides, and the override file enables us to add extra services inside the network I talked about earlier. And we do that because otherwise the Cypress container can't access the other containers inside the network. Because remember, I don't expose the ports to the outside world, so you can't connect to the API from the outside world. So you have to be inside the compose file to actually start running your Cypress tests. So this is the Docker Compose override files we use for Jenkins. And as you can see, we have we use a custom built image. We used to use a custom built image, which copied a little script, and I think it was based on Alpine, if memory serves well. We now have migrated to your image actually, but you will see that later on. So, and actually, what it does is you see the command which is being run. It's the command we have. Well, it's the command we use to run Cypress with, and we will go to that command in a second. You will see the volumes, which actually just means that whatever the root is, map it to my /var/mdp. And we set some environment variables, and then we wait for the service to start.
Gotcha.
Let's see. Yes. So this image, I actually highlighted it. Wow, very nice. And this is the volume we map, the environment variable, and the command which will be run.
So this is the command, right? The shell script
so
you run there.
Yes, this is the shell script. What it does is actually very simple. It waits until the API has finished loading up. And when it's done, it will just run the Cypress command. So we have as you can see, we have the Cypress run and then the record and then the key. And this will actually talk to your dashboard, and it will send the results over to your dashboard.
Gotcha. So this is how you actually started, right?
Yes, this is how it was in the beginning. So when we go to the Jenkins file, then we have the override I talked about earlier. So we compose that in a string for later use. So we have the compose file, and then we override it with the Jenkins file, so that we can create one network. And then we have a stage, and in the stage we say end to end, and then we just do a run of the Cypress container. So we make sure we listen to the Cypress container, because when the Cypress container has finished executing, we know the tests have been run, and then we can process the result like so. So the run command actually means don't start any linked services, but as you have seen, everything is linked in our Docker Compose, but then remove everything after run. So this is how we used to run Cypress. Well, we still run it in kind of like that way, but I don't want to give away any spoilers. So.
Oh, sorry, I pressed the wrong button on the keyboard. Sorry.
Oh my God.
Okay. It happens. So we cover this, and
yeah. Okay, there we are. Yeah.
Okay, continue. Okay. Sorry about this.
Okay, so how long did it all take? I think around 10 minutes. So that was like I talked about earlier, we do a lot, at least 400 releases to productions a year.
Mm-hmm.
So waiting 10 minutes, only 10 minutes for your test run to be completed. That's quite long because we have other stuff to do as well, like compiling the API and bundling the JavaScript files, and that also takes a whole lot of time. So in the end, we are looking at, I don't know, builds of 17, 18 minutes.
Yeah.
That's bad because that's really slow, right? And you had to wait for it twice because we work on pull requests. So you had to wait first for your pull request to be green, and then after that, you had to wait for master to be green, and then the containers were shipped to our accept environment. And well, after that, releasing to production is easy, right? Because when you have created your container, you can just flip the pointer to a different container, and then you're live, right? But building a container, yeah, sometimes you had to wait for maybe 30 minutes. When a quick fix had to be made quick, it was just way too long.
So what did you do?
So, like I said, that wasn't really acceptable for us. So DHL is all about fast delivery, but if the IT guys can't deliver fast, well, it's a shortcoming, right?
Yeah.
So, and also another problem is because the test code base, it will just expand forever, just like the universe will.
Yeah.
So this is a problem, and that the test code base will only become bigger. The problem will also become bigger. People will start to write less unit tests, and that's a bad practice in general. So at first, we tried our own version of parallelization, right? So we had some experience with Jenkins, and in Jenkins, you have the parallel keyword. So I couldn't find a screenshot from back in the old days. I think it's almost a year ago. I don't know, like ancient history. So I've made a screenshot of another parallel step, and here you can see like the build steps of the different projects, right? So you have API and you have the PWA, B2X, and C2C. So these are all built in parallel, and we also had like our tests in parallel. So we split our Jenkins file up like so. So this was actually our test to run block back in the day. So in Jenkins, you have the parallel keyword, you see.
Yeah.
So and then like we had 4 different websites. So we were like, okay, let's just run all those different websites in parallel. Easy, right?
Easy.
Yes. So this was actually our code back in the day, and we figured, well, the B2X site was the biggest application of all. So maybe we can use the suites and just split the tests in like 2 parts, like maybe 50% in one suite and 50% in the other, and then maybe the time will be shorter to build, right?
So you did it manually, right? Kind of roughly. Okay, first couple specs here, and the rest here.
Yes. So you can see the C2C and the admin and the PWA all got their own test suite, and we all made different containers, right? So you can see the run of the B2X suite, and you can see the run of the C2C suite, and so forth. So there you go. So we have 2 builds for B2X. I only highlighted that. That's fine. So when we go look at the Docker Compose configuration of one of those suites, you can see that only the commands differed. So, and the only difference was that we gave another set of arguments which specified, okay, this container you should run these tests, and this container should run these tests.
Right.
And we tried to build we try to steer it with some environment variable. So actually, it was quite a success because I mean, from going from 10 minutes to 7 minutes, it's quite okay, right?
Yeah, 30% improvement.
Yes, so we were happy at the time, but still, the test took longer than the build took. So yeah, it was not all happy cakes in the DHL Parcel land. So, and there were other problems as well. So remember the two suites I talked about. Well, everyone just added tests to suite one, right?
Right.
So suite one was becoming bigger and bigger, and you know when you're building features, you're not really thinking about how to best optimize your test code because you're adding value to the business, and sometimes, usually, test cases are always the last step, right?
Right.
So sometimes we were building features and then, okay, we have to build an end-to-end test share, fine. Let's just add it in suite one, right? So
Yeah.
suite one was getting bigger and bigger and suite two was just small. So people needed to be taught all the time, but now maybe you can split it and stuff like that. So end result was so less tests were being written.
That's the best solution.
Yeah,
Honestly.
maybe. Yeah. Maybe so. So then one day we were looking at the dashboard, and well, actually there was really a big black like a big black border in our test suites, right? And usually most people have ad blindness, so I first thought it was an ad, right? And then I read the ad, and then oh right, so I'm talking about this one. So maybe
Yes. Yeah.
maybe it will be the first time people will notice, but this is actually really useful. So, and then when you click on that one, it will say, "Ah, just add 4 more machines, and then your test will be a lot faster." And I'm like, okay, how do we add more machines?
More Jenkins containers.
Yeah, so here we go. There are several ways, and we will view 2. So first one is Jenkins. Let Jenkins do the work, right?
Yeah.
We already have some experience with the parallel option, so why not just make more stuff parallel, right? So there you go.
Oh my.
Yeah, so we have the parallel tag, and here's the B2X part. So we added 4 machines, and we added 3 more machines to the suite 2, right? And then two machines to the C2C side. 1 for admin. Admin is really small, and then a few for the consumer side. BWHA, right? So
Right.
and that suddenly took 6 minutes. Ah, very nice.
But it's
So,
interesting because you actually double the number of machines, right? But you only got what, 1/7 improvement.
yes, yeah, we were puzzled by that as well. So one thing we tried to optimize was like, okay, maybe we should just combine the B2X side, because we figured out Cypress is more is more able to tell us which tests to run than we can, because Cypress constantly monitors the test times and so it probably can tell us way better,
Right.
which tests to run and how to parallelize those. So we were like, okay, let's just group the B2X and then try again, right?
Yes.
So that shaved another 30 seconds of the test run, which was nice. But like you said, it's weird, right? Because we went from 7 minutes to 5.5, and then we started thinking, well, if you go look at CPU times, you have the first big load at the beginning of the test, because all the 4 projects are being executed at the same time, right? So you have the B2X, C2C, admin, they're all running at the same time. But when admin and C2C end, well, we still have to wait for the other 2 to end, right?
Right.
So, and so this part is the wasted CPU, and I call it wasted CPU because when you're waiting for a Jenkins build to complete, time is your friend.
Right.
So, and if some CPUs could be used to run extra tests, well, why not use those CPUs? We were claiming them in the beginning, so why not just use them until the entire run was complete, right? So what we did was we grouped the tests. So we went back to the run Cypress script, and what we did was actually very simple. Instead of having different containers running different test sets, we just made one script with all 4 projects.
Right.
And we said, okay, first run the B2X tests as a single container. Then please run the PWA tests, then the admin tests, and then go to the C2C test for me. So what this actually means, I try to illustrate it with a little. So imagine we have 5 agents, 5 machines, right? 5 Docker images, 5 runs.
Right.
So in the first phase, all machines will be busy working with B2X, right? And Cypress is managing these agents and telling each agent which test to run. So
yeah, this is your -- parallel flag that does that.
Yes, exactly. So and there's communication between the dashboard and the machine. So every time a test finished running one test, it will ask, okay, give me the next, right?
Right.
So, and after a while, the B2X tests will be done, right? So 2 of those machines could start at the next test run.
Right. So we're done. We don't have any more B2X specs. So we just go to the next step, right? And we run PWA specs. And then more machines switch as we finish. And we're never idle, right? We're always busy with something.
Yes, exactly. So as you can see, and then I put dots in the end, so you can fill in the dots yourself. Nice. So what this meant is now we had one single command, right? And we just added more machines. So we did end-to-end 1, end-to-end 2, and just copy paste, right? We add more machines. Because the script will just run all the different tests. And when it finishes with one suite, well, it will continue to the next one.
So this is identical command. Everything is identical. It's just in Jenkins, in order for you to define jobs for parallel step, you just have to give them different IDs. That's it. That's the only difference.
Yes. Well, I think the string it doesn't have to be. You don't have to be to input the 1, the 2, or 3, but in the overview it looks nicer, right? Otherwise, it will just be end-to-end like 8 times or 12 times. I don't know. So what this meant? Short execution time. Very nice. So we went from waiting until the biggest suite was finished to, well, if you finish, just go to the next one. So it meant shorter execution time. So in the end, it was 4.5 minutes. Very nice. So we went from 10 minutes to 7 to 4.5. It's quite big.
Right.
But still, there were some problems with it because Jenkins and Docker, they are not the bestest of friends, so to speak. So we first had to tell Jenkins, well, first try to spin up the entire environment, and then continue with testing. If you don't do that, and you will start with the 8 different test stage at once, several Docker Compose images will be started at once. So instead of having one network of containers, you start having 4, 5, 6 networks of containers. So that's bad. You don't want that. So before testing, we should tell Jenkins first to spin up the entire environment, and then continue with the tests. And also, what you saw above, it was quite repetitive, and you could solve it with a for loop in Jenkins.
Yeah,
it's I don't know. It was not nice to look at, but it's only taste, I guess. What works works.
So what did you do, Rick?
So, well, there was another strategy. Let Docker do the work. So Docker, and especially Docker Compose, also has a way to spin up more machines, so to speak, which is very easy. You can just say to Docker, okay, we have this DHL end-to-end Cypress container. Scale it to me to 8 machines, and then it works. Nice. There you go.
Yeah.
One simple magic command, and then we could later go in and make the number higher, lower. It's very easy, very maintainable.
It's very nice. So you're showing me the whole kind of Jenkins file, or like that part that runs end-to-end tests. And it's literally one line, but just tells Docker Compose, hey, create 8 containers, identical, and just run them.
Yes.
Right. And then Cypress test inside will all join, and the dashboard will tell them what to run one after another. So that's very simple now.
Yes. So we were like, wow. And it was it shaved 1 minute of our test execution time. So we were like, whoa, this is like the holy grail of testing, right? So we done? Holy cow. Not really. No, we're not done. Because there was one simple thing that I told you before, Jenkins and Docker, well, they are not the bestest of friends, right? I think Jenkins was born way before Docker was born. I think Jenkins witnessed the age of the dinosaurs when it was still called Hudson, I guess.
Yes.
I don't know. So, but what Jenkins actually did was imagine those 8 Docker containers running, right? And then one of those containers will be the first to exit the running steps, right? So eventually all 8 will stop running, of course, but one will be the first. What Jenkins actually did was take the exit code of the first container that stopped and use it as a way to indicate the build status. So when the first container exit as successful, the build was successful. That was bad, right?
Yeah, it's bad. But
yes.
I find it hard to believe, Rick. You know, like it must be something from Docker Compose side, right? Because Docker Compose spins 8 containers. It has to exit with the exit code, right? I believe it's Docker Compose fault. What do you think?
I don't know. Could be. It was a problem. So
true. Nobody cares whose problem it is unless
yeah, I know.
Yeah.
So we had a few tests that were failing actually, and we figured it out. Maybe after 4 days that some tests were failing because at that point the builds were getting flaky, right? So at one time the build was green, and the second run it was red, and it was like, okay, it's just really weird, right?
So sometimes you will see like Cypress dashboard tells you have a failing test, but you're like, no, my CI is green, right? And then you figure out, oh wait, something is wrong. Yeah.
So my build is green. I can click the merge button. It's fine, right? And well, especially when you made backend changes, right? When you made backend changes at parts that you know for certain didn't affect any front end tests, then you're like, okay, well, it's probably not my fault. The build was failing, so
Right. Ship it.
yes. So that was bad, right?
Yeah. So what did you do to solve that? Like,
Well, we did two things. It's actually a little bit of Linux magic.
mhm.
So first of all, we needed to trap the exit code to make sure that the exit code of each of the 4 individual steps highlighted here were not lost.
Mm-hmm.
So what we did was the following. We had an error code set to 0. Then we have the trap command, and it defines and activates handlers to be run when the shell receives signals. So what we just did was add the exit code to the error code, and then at the end of the run, we just said, okay, exit with this error code. So we knew that if any one of these 4 tests gave us errors, then the exit code would be higher than 0.
Right. Which will be like CI will fail on that.
Yes, well, for one container.
Right.
For one container. The next step was we had to make sure that all the exit codes were respected, so to speak. So we still have our Docker Compose upscale with our 8 containers, right? There you go. And we have a few extra commands. This is actually for logging, so we can see everything exit is right. So this piece is the magic right now. So we have, this is the Cypress error code we now catch inside of a variable, and then at the end we will just, okay, if it wasn't 0, then we will error the build. So the docker compose ps command will yield something like this. As you can see, we have our 8 machines, and I picked a green example, so you can see all exit codes are 0. Very nice. And then we have the command which actually does the following. So we have docker compose ps -q, which only prints the IDs. So we use those IDs to get the exit codes of those containers, right? Then we invert match those anything other than 0.
Right. So it's like exit 1, 2, whatever it is, but not 0. Yes.
We will line count those, and then we'll remove all the spaces, and this will actually be the exit code of all containers run Cypress tests.
So it will tell you like one container, like 1 if one container failed, or 8 if all 8 failed.
Exactly. So in summary, we went from 10 minutes running just each test consecutive to 7 minutes using a little bit of parallel and trying to divide our tests into smart suites, to 4.5 minutes using Jenkins parallelization, and then switching to Docker parallelization in 3.5 minutes, all with the same test space. So when we were doing that, there was things we learned, and we would like to share those with you guys. So one of the things we learned actually was when you have 2 asynchronous, I don't know, 2 calls, like you have get orders calls from your server, and then you have a get setting call from your servers, like 2 of the same happening at the same time, right? It's better to group them inside the array. The reason for this is when you have it like this in your Cypress test, then sometimes the get settings will finish before the get orders will finish, and then you're still waiting on orders. And when that finally gets in, it will wait for get settings, but get settings was already finished, so your test will be waiting for nothing, right?
Right. So you want to wait for all of them at the same time.
Yes. Another thing is that please try to avoid waiting in milliseconds. We have a very big Jenkins machine with 64 cores, and it's really a beast, right? But sometimes also the beast can have a little bit of downtime, like many cores building different projects, right? So sometimes the render will be a little bit slow, or maybe right, the API calls will be a little bit slow. So what happens is, okay, I think sometimes you just want to wait a little few seconds, right? But how many seconds is enough? How many milliseconds is enough? You don't know. You don't know how Jenkins does its work, or how Docker manages its containers, right? So it's better. It's always better to just wait on a specific XHR request, or check for a certain tag inside your HTML, because sometimes it takes a second, sometimes it takes 5 seconds, and you don't want your test to fail on stuff like wait 10 seconds, wait 1 second, right?
Yes. And you don't want to waste time by waiting for 10 seconds if that what you're waiting for already happened after 10 milliseconds, right?
Yes, correct. Another thing that's really hits home with parallelization is and that's really important, but make your test autonomous, which means that if you have a test that depends on another test to finish, with parallelization, you don't know when the test will be run, right? It could be before you run or after you run, so you don't know that, and you don't want your test to fail because some prerequisite hasn't been set yet. Another example is if you have a test that will check how many elements are in a list. For example, if you just add orders to a list, and you check for one order, because when you run your test consecutive, it will always only create one order. But then you add a second test, which adds the second order to your list, and then suddenly you have 2 orders. You don't know when the first test will run in retrospect to the second test side. So in the first test, you can suddenly have 2 orders because, well, that's just how Cypress manages how your tests are being run. Does that make sense?
Yeah, so you don't want results from one test,
Yes.
right, to propagate, and then the second test has to have a first test run before it, otherwise it doesn't have the data. You want each test to be independent.
Yes. Also, one of the things we figured out was well, Cypress knows a lot, but it doesn't know everything.
Right.
So when Cypress says, yeah, just add 5 more machines and then everything will be cool. Well, you don't know that. Cypress doesn't know your CI. So if you have a build machine which cannot spare the resources, well, it might just slow your test down. So it's always good to experiment with how many machines to add, and not just blindly add machines.
Oh yeah, you have to measure first and then do a change, measure again, and see if it actually solves it. Otherwise, revert.
Yes, and also when your test code base grows, sometimes the order in the which tests are run changes. So suddenly it will make sense to add more machines, but sometimes it will make sense to shrink the selection again, right? Also, and this is the biggest one, know when to stop optimizing, because in the end it's all about delivering value to your customers, and just fiddling with your build times and in your tests, right? And not adding extra tests or adding extra features. It's just, well, you have to know when to stop, right? It's a never ending story. So please enjoy this opening tune for the rest of your day.
Thank you, Rick, so much for this presentation, and especially for concrete examples, because I think many people will find them very useful and insightful. We have a couple of questions that people ask Before we go to questions, the link to the slides is on the top of the slide, and we'll send it to everyone who has registered. If you want to ask Rick a question on Twitter, use his handle. You can ask me a question on Twitter as well. So why don't we go to the questions? We have top questions right now that people have voted for. Rick, do you mind taking the first one? What is the architecture of your test? I'm not sure what the question is, so you can interpret it as you want, really.
Okay. Well, the architecture of our tests. Well, I don't know. It's a difficult question because, well, we have all different kinds of tests being run, right?
Mm-hmm.
So, example for the B2X side, we have tests related to creating the labels. We have tests concerning imports of really big files.
Mm-hmm.
So we like to think more about how many customers are affected by this particular feature, and then we try to heavily test those features more than the features that are barely used. Like for example, the admin side, which has a Cypress end-to-end test, but well, the user base is so small.
Yeah.
So we try to focus more on the B2X and the more heavier applications for testing.
And if I might ask, so each test opens application, does something through the user interface and checks results, right?
Yes.
And it's very real because you actually have the services running. So it's like full end-to-end test through the API and back, right?
Yeah, that's the big advantage of using Docker and Docker Compose is that you can spin up an entire environment, right? So every microservice is available for you. So we have the label service, which can create labels for us. And the API has a live connection between those two. So actually the amount of mocks, like the Cypress stubs and mocks, right?
Yeah.
We actually only use that in like 2 or 3% of all our Cypress tests.
Gotcha. Nice. I kind of like this question. How many tests are in a run, right? Kind of a basic, right? This one. How many tests altogether, approximately?
Last time I looked, I think the B2X suite was around 130 tests right now. I think C2C is something, I don't know, 30.
Gotcha.
40
So
maybe.
Approximately 200 altogether, probably.
I think so, yeah.
Nice.
Something like that.
This is a good question that got a lot of votes. Is there a way to use parallelization in Docker with one of the Cypress Docker images, like the ones like we built like Cypress base? Or do you have to build custom Docker Compose file, right? So this is kind of mixing the image and the Docker Compose file.
All right. Well, we actually use the Cypress base image right now in our tests, because when you do a Docker Compose file, you can specify the image of each individual service. Right. We actually switched to the Cypress base image recently. So you don't have to homebrew your own images anymore, right, which is nice. I think back in the day when we started to use Cypress, you guys didn't have a Docker image yet, so we built one from I don't know, I guess it was Alpine or something like that. Then we added the node module install to that, and then we uploaded it to our own Docker Hub and just used that one. So, but there is, I think, if you can use existing images, it's always preferable, I guess, than making your own homebrew images, because when you use other people's images, the support will also become other people's problems, right? So that's always nice.
Very true. Very true. Thank you. Yeah. Did you use did you compare Cypress with other frameworks, right? Did you use something else before you switched to Cypress, or are you still using something else in addition to Cypress for testing?
For end-to-end testing, we are not using anything else other than Cypress. So when I started at work at DHL Parcel, Cypress was already up and running. So, but I used Selenium in the past at my old employee. But I haven't compared Cypress with other frameworks in that regard, regarding to the work at DHL for that matter. So I can't really answer that question, but
so let's go to the next question.
Yeah,
right?
since it's a Cypress webcast, it's Cypress is the best, of course.
Thank you. I'm trying to. This one is a good one because you said that the tests should be autonomous. How do you make sure your tests stay autonomous? For example, on a clean environment with no data, how do you test the details page of an item, right? Does the test create the data? Like, what's happening?
Yeah. So we have there are two different approaches because first of all, we have of course we are using Docker Compose, but we also have an image of our database inside the same network, right? So we can load the already up front before we start up the container or the whole Docker Compose network. So when we want to test a specific page, we make sure that the data is already available on our test database.
Can I ask then if the data is available, right? You can load it using fixtures, right? Because the next question that got a lot of votes is, what is your approach regarding fixtures? Do you load data in your database via Jenkins job or follow approach? Like, how do you pre-fill any data into the image?
Well, we use two approaches. We use a load data when we start up the whole network. So we have a separate script for that. Just it's a load data container that's just wait until the database has finished loading, and then just puts all the data inside the database.
Gotcha.
We also use a few fixtures, but that's mainly for providing like images or other stuff to our user interface.
Excellent. So we're almost out of time, Rick, and I want to thank you. So why don't we take one more question before we say goodbye? Is there anything that you see that kind of catches your eye on the page right now?
Okay.
How about this one? Do you include backend tests in your Cypress tests, right? Or do you only test end-to-end? Like what's going on there?
Well, we have the pure backend tests. Well, we have a lot of microservices, so we just use like integration test and unit test for the microservices. So in that regard, we don't actually post. We don't actually go to the database and see if the data has been landed there. But we do check the end-to-end cycle, right? So we post something on a form, and then we check if the data has been in the list. But for we don't actually check the backend side of things. So it's more like a black box testing.
Right.
So you enter some values and you expect the values to show up. So we don't actually look into the database.
Well, thank you, Rick. I want to thank you so much for taking your time to prepare this presentation, for joining me today and going through the Jenkins parallelization and Docker parallelization. And for people who have not noticed, Rick's background is virtual, but it's a DHL warehouse, if I understand correctly, right?
Yes,
it's a beautiful virtual background.
Thank you. It has been made today.
Well, thank you, everyone. Hope you're staying safe and talk to you later. Bye-bye.